Welcome to our competency-based question series designed specifically to enhance your conceptual learning and understanding. In a given LCR series AC circuit, the inductive and capacitive reactances are given as 400 ohm and 600 ohm respectively. If resistance R in the circuit is 100 ohm and the maximum input voltage of the AC supply is 100 volt, then we have to identify or find out the following things. So let's draw the circuit. We are having a resistor R, an inductor L, and a capacitor C, and they both, all the three are connected in series to an AC source. And this AC source, it is having maximum voltage V naught as 100 volt. The value of resistor is given to us as 100 ohm, and the value of L is not given, but XL is given. XL is inductive reactance, and that is equal to 400 ohm. Similarly, the value of C is not given to us, but XC is given, that is capacitive reactance, and it is equal to 600 ohm. So we need to find out the net impedance of the circuit in part A. So net impedance Z, it is equal to under root of R square plus XL minus XC whole square. So we can directly put the values. No need to compute XL and XC. They are already given to us. So we can write that is equal to 100 square, value of R is 100, plus XL is 400, minus XC is 600 whole square. So when we solve it, it will be 100 square plus 200 square. So we can take 100 square as common, and it will become 100 square, 1 square plus 2 square. So that will be equal to 100 under root 5. So the impedance of the circuit has come out to be 100 under root 5 ohm. In part B, it says find the maximum current in the circuit. So we know the maximum current I naught, it is equal to the maximum voltage V naught divided by the impedance Z. V naught is 100 divided with 100 under root 5. Z value we have obtained in part 1. 100 gets cancelled out with 100, and we are left with 1 upon under root 5. And if we rationalize it, multiply and divide it with under root 5, it will be equal to under root 5 divided by 5 ampere. So that's the value of maximum current in the circuit. And in part C, we need to find out the maximum voltages across each of the elements. So we know the maximum voltage across resistor, it will be I naught multiplied by R. So that is VR max. So I naught value we have obtained in part B, and it was 1 upon under root 5 ampere. So we can write 1 upon under root 5 multiplied by 100, because 100 was the value for resistance. So it will be 100 upon under root 5, and we can rationalize it, multiply and divide it with under root 5. That will be 100 under root 5 divided by 5. So the final value will be 20 under root 5 ampere. So this is the maximum current across the resistor. Similarly, the maximum voltage. So this has to be V, because we are finding voltage. So the maximum voltage across the inductor, so VL max, it will be I naught multiplied by XL. And the value of XL was given in the question as 400 ohm. So we can write it as 1 upon under root 5 multiplied by 400. Again, we can rationalize it. It will be 400 under root 5 divided by 5. So further, we can write it as 80 root 5 volt. And similarly, the voltage across the capacitor, maximum voltage across the capacitor is maximum current multiplied by the capacitive reactance. And that is given to us as 600 ohm. So that will be 1 upon under root 5 multiplied by 600. So it will be 600 under root 5 divided by 5. So again, we are rationalizing, multiplying and divide it with under root 5. So we will be getting 120 under root 5 volt. So these are the maximum voltages across each of the circuit elements. That is part C solution. And then, sorry, part D solution. And then we have to find out the maximum voltage across the three elements. That is part D. It was C. So we have to find the sum of all the three. So V max will be 20 root 5 plus 80 root 5 plus 120 root 5. That will be 220 under root 5. Approximately it is equal to 492 volt. So when we multiply it with the value of root 5, we'll be getting 492 volt. And in part E, it says, is it possible to attain the value obtained in part D in the given circuit? So, no, we cannot achieve 492 volt in the circuit because these values are calculated with the phase differences. So when the phase difference across the capacitor is some value, then the voltage will be different. It is the maximum that it can have. So in any of the case, it is never possible that each of the elements are having their peak values. So we cannot achieve these values, that is the value of 492 volt in the circuit, as the value of voltages has to be calculated along with phase difference. And hence, there will not be any point when each of the circuit elements will be having the peak values. So their sum will never be equal to 492 volt. Thank you. Keep learning, keep practicing, keep excelling.